Tonight, we're going to continue with the Softjaw lathe project. Currently, we're looking at the project at the level of completion where we left off last class. If I go to the project page, you'll notice that there's a lot less instructions than the previous projects. And as we work our way through the semester, we want to become more independent of those step-by-step instructions. We want to be able to approach it as if we were at work and we have to figure some stuff out. I did provide a tool list. A tool list will usually be determined by what's available in your shop. If there's any specialty tooling needed, you'll have to purchase it. So I'm looking at the drawing. And then I go back to Mastercam. And based off of what we did in the past, I still need to create a material representation. I'll need to create a coordinate system that's usable for us. And then I can start creating toolpaths. Something else, I've got a level called name. We're going to put our initials somewhere on the top of the part. So let's do that next. We'll create our initials, make the name level the active level. I'll probably draw in some construction geometry to help me place my initials. So let's draw a line from the 3 o'clock quadrant of this circle to the midpoint of this edge. We'll delete it after we place the initials, so I'm not too concerned about what level that line is being placed on. Go to the home tab. Let's check the color, the wireframe color. Let's use something that's visible, a little bit more visible on the part. I'm going to use this color right here. It's like a burgundy color. I'll go to wireframe, create letters. For the text height, let's try 0.25. And then in the letters field, type in your first and last initial. Hit enter. And then I'm going to deliberately, well, I was going to click off of the part, but I just realized that my initials or my construction plane is currently set to the front. I need to set my construction plane to the top. So while I'm in this tool, I can come down here and for C plane, set at the top. I'm also having some issues with the spacing of my initials. Set that to 0.05, a little bit better. So I'm going to deliberately click off in space, place the initials off of my part. Then I'll select OK. I'm now going to draw a line from the 3 o'clock quadrant to the midpoint. So I'll go to line. Let my cursor lock on to the 3 o'clock quadrant. Then I'll let my cursor lock on to the midpoint of this edge. I'll select the green check to exit the tool. To place my initials, I'll go to transform, translate. I can window select my initials, select end selection. And now you'll see a center point appear on our initials. And there's a gnomon or a triad, an axis control attached to that point. I'm going to use the vector from to method. So be careful here. I need to select the reselect icon. And this icon exists here and here. They're different. They're named the same, but they're different. I'm selecting the reselect that's under the vector from to. I can now zoom into the point centered on my initials, lock onto it, left click, and then I'll lock onto the midpoint of this construction line that we drew. Left click. I'm going to set the method to move. And then I'll select OK to exit the tool. And once you place your initials, once you verify that they're in the correct location, you can select that line, hit delete. If I look at it from an isometric view, this would be a good time for me to save my work. And then to clear my colors, right click, clear colors. And I'm also going to change out of a translucent view for the time being. How's everyone doing?
Good.
Nice.
Yeah,
I've done that several times. What's that?
Oh, I got delayed a bit. I can't for translating it. What do you select again? You go to transform, translate.
And then I use the reselect under start from. If I go to transform,
Reselect. Okay.
and then you're going to select the center point
Uh-huh.
of the initial, and then select the midpoint of that construction line. And
Got
I use
it.
the method move. That way I don't got to go back in and delete the original. All
Got
good?
it. Yep.
Perfect.
Thanks.
Hey, you're welcome. All right. The next thing I'm going to do is I'm going to create the material representation. This will be the solid model that represents our material. And we're going to create several other solid representations from that solid model. I'll make the material level the active level. I'll go to the Home tab. And for the solid color, let's change it to something that we haven't used yet. I need some color variations on my screen so I can differentiate between the different items. I'm thinking this purple right here, or magenta-like color. We're going to use the bounding box tool to create the material around the part. I'll go to the wireframe tab. We're going to use the bounding box tool. Mastercam is prompting me to select one or more entities. Use Control-A to select all. Now you need to be careful. You can't have your initials visible on the screen at this time. If I select Control-A, everything becomes selected. I'll select End Selection. And you can see that Mastercam's creating, or the bounding box tool is creating a rectangular envelope that captures everything that we just selected. What I'll need to do is I'll need to increase it a little bit. I need material on all sides of the part so that we can machine away the material and get a nice machine surface on all of our faces. So let's do this. In the X, I want to use numbers that, well, for the Y and the Z, we're gonna have to use numbers that are readily available. We're gonna get a 12-foot length of material. So for the Y, let's set this to 1.25. For the X, we can set this to 3. This would be controlled by the saw cut. For the Z, we're going to make this out of a 1.5 thick piece of material. I need about 20 thousandths on the top of the part so I can face it off and get a nice machine surface. So if I pick select the top face, you'll see this arrow appear that's perpendicular or pointing straight out of the face. If I position my cursor over that arrow, you'll see a scale appear, and you'll also see a field where we can enter a value. Type in 0.02 on your keyboard, hit enter once. You'll see that 20 thousandths added to that face. Hit enter a second time. I'm now tumbling my part, so I'm holding my middle scroll wheel down. I'm moving my mouse, tumbling the part. I need to add 0.23 to the bottom. I'll pick select this face. I'll position my cursor over the arrow. This time I'm typing in 0.23. And that 0.23 is coming from, I had a quarter, I was planning on adding a 1/4 inch to get a 1.5 inch thick piece of material. I added 20 thou to the other side. I have to add the difference to the other side, 0.23. I hit enter once. I hit enter a second time. You'll now see that the overall thickness of the material is 1.5. If I hit enter a third time, it creates the bounding box, and I did that incorrectly. I forgot to select the solid. So what I'm going to do is I'm going to escape out of here, edit, undo. So file, my bad, undo. I'll do that one more time. I'm going to go to wireframe, bounding box, Control A to select everything. In the X, set that to 3 inches. In the Y, 1.25. In the Z, I want to add 20 thousandths to the top, so I'll select the top face. Position my cursor over the red arrow, 0.02, enter once, enter twice. I'm tumbling my view. I'm selecting the bottom face now. Left click on it. Position your cursor over the red arrow. This time we're going to add 0.23. So 0.23, enter once, back up, 0.23, enter once, enter twice. Before I hit enter that third time, I'm going to scroll down where it says create geometry. I'm deselecting lines and arcs and I'm selecting solids. From here, I'll select OK. I now have a cube on my screen. If I go to a shaded mode or a translucent mode, I should say, I can now see the part suspended inside of the material, and we're going to machine away the material to reveal the part. You can see I've got, if I look at it from a front view, I've got a little bit of extra material to machine away for my first operation, or that'll be my first facing operation. We're going to take 20 thousandths off the top of the part. We'll be holding on to this extra material down here in the vise. So everything looks good as far as the material representation is concerned. I now need to create a new coordinate system that will work for my first operation.
Hey, Professor, sorry
Yes,
to, I'm sorry, can you just redo that one more time, the material? I couldn't find the undo button and I missed it all.
Okay, not a problem. So I'm going to select this and delete it. And I'm going to go to wireframe, bounding box tool. To select everything on the screen, Control A. And selection. Now we're creating an envelope that captures everything that we just selected. I want to add extra material all the way around. So in the X, I'm going to add 3 or set it to 3. In the Y, 1.25. And then in the Z, we have to do each face independently. So I'm going to start by selecting the top face. I'm going to add 20 thousandths to the top face. Position my cursor over that arrow, 0.02, enter once, enter twice. I'm tumbling my view. I'm now selecting the bottom face. Position my cursor over the red arrow. We're going to add 0.23, 0.23, enter once, enter twice. And now here's where I made the mistake last time. Before you hit enter that third time, where it says create geometry, deselect lines and arcs and select solids. From here, if I hit enter, it creates the solid model of the material. And I can exit the tool at this time. I'll select the green check. And actually it's trying to get me to select the next set of geometry. So I'll just hit escape to exit the tool.
Got it. Thanks.
You're welcome. So we've got our material. We now need to create a coordinate system that will work for the first operation. Go to your plane manager, planes. To create a new plane, select the green plus sign, and then from the drop-down menu, select from solid face. I'm going to select the top face of the material. Now we have 8 options to choose from. It just so happens that this is the option that I'm looking for. Z will be perpendicular to the flat solid face, and then the XY plane can rotate in different directions. So this is what I want. The location is not where I need it to be, but the orientation is correct. So I'm going to accept this. I'll select OK. Inside the parameters for this new plane, let's start by giving it a name. We'll call this first operation. Don't worry about the origin here. Where it says set as, I've got WCS checked, T plane checked, and C plane checked. To reposition this coordinate system, I'll select reselect. I'll move my cursor into the graphics area. And I'm going to place the coordinate system right here. Bottom right corner. Actually, we'll call it upper right, bottom of material. So top right corner, bottom of material. Let your cursor lock on to the endpoint, left click. If you need to move it again, let's say you accidentally placed it incorrectly, just select reselect, and then let your cursor lock on to the correct location. Left click. From here, I can exit the plane parameters. I'll select OK. Right click on the screen, and I'll look at it from an isometric view. And this would be a good time for me to save my work. So file, save. How's everyone doing?
Good.
Nice.
Professor, I kind of missed this last step. Can you redo it, please?
Redo the coordinate system?
Yes,
Yeah, no problem.
please.
Okay, so let's do this. I can delete this. I don't want delete. Oh, wait a minute. Hold on. There we go. You can't delete something if it's current. Delete selected. All right, so to create a new coordinate system, I'll go to, you need to have the planes manager open. Go to create a new plane. And then I'm using the from solid face method. I'll pick select the top face of the material. Now I'm seeing the preview or a preview of the coordinate system. If you select a flat solid face or a solid flat face, Z will always be perpendicular to that face. And then you can cycle through the other options if the first one isn't what you need. It just so happens that the first one is what I wanted. So I'm not worried about the placement just yet, just the orientation. So from here, I'll select OK. In the name field, so now I'm in the parameters for the plane. In the name field, let's call this first operation. If you scroll down where it says set as, I have WCS checked, T-plane checked, and C-plane checked. To reposition the coordinate system, I'll select reselect. And then when I move my cursor into the graphics area, you'll see the coordinate system attached to my cursor. I'm just going to place it top right, bottom of material. Let your cursor lock into position, left click. Now that the coordinate system is where I need it to be, I'll select OK. Right click isometric, and then I'll save my work. Okay. The next thing that we're going to need to do is we're going to start creating toolpaths. But before we do that, we're going to create a stock model that represents our raw stock. How's everyone doing up to this point?
You said it, so your plane is checked in the top, right?
Plane is checked in the top.
Are there planes here?
Oh, this one right here?
Yeah.
If I select that and then hit equals. Oh, that green check means it's being used for something. This is what controls what's current. This is just
Right.
telling me that it's being used for something else, be it not quite sure what's using it just yet. Oh, I think I know what's using it. Oh, now it changed. That's levels. Hold on, planes. I think this coordinate system, the new one that we just created, has some ties to this one. Does that make sense? And so that's why this one is currently checked. And as we create toolpaths, and the toolpaths are directly associated with these coordinate systems, green checks will appear next to these also. So let's do that. Let's go to the toolpath manager. We'll need to bring in a machine definition and make some changes to the default settings. So if you don't have your toolpath manager visible, you're going to go to View. In the Manager section, select Toolpaths. Currently, the Toolpath Manager is empty. I'll go to Machine. We need to add a machine to our toolpath, or we need to add a machine group to our Toolpath Manager. Go to Machine, Machine Type, Mill, and select the default. Mine seems to have issues. I've got a red X next to it. Don't know what that's all about. Probably find out soon enough, but that seems to be new to me. Interesting. I usually go to Machine, Mill default. Yeah, you got red X's next to both of them. So, all right, hopefully that resolves itself. Okay, so let's start by setting our job folder, or setting up our the job folder. Go to File, Project Manager, and I want my NC files and my NCI files saved to the job folder, or the working folder. That's where my Mastercam file is currently saved to. I'll select OK. To get back to Mastercam, I'll select the back arrow. I'll expand the properties underneath the machine group, and then I'll select Files. Let's start by renaming the group. Instead of machine group -1, I'll call this Haas VF2. Let's see here. From here, we're going to set the maximum RPM. So select Edit. In this field, you'll see Mill Spindle Group. Expand it. Select the plus sign and keep selecting the plus sign until you see Tool Spindle. On this dialog box, or on this page, set the maximum spindle speed to 10,000. Once you do that, select OK. That'll take care of all the changes that we need to make to this page. Select OK again. From here, go to Tool Settings. For the default program number, give it a 4-digit number of your choice. Do not use 9,000 series. So I'm going to call this one 7,777. For the feed calculation, select from material. For the toolpath configuration, I'm checking assign tool number sequentially. I'm checking warn of duplicate tool numbers, and I'm checking use tools, step back and coolant. From here, go down to sequence number. Start with 1, and then have them numbered in increments of 1. These will be our lines of code inside of our NC file. For the material, we're going to make this out of 6061 T6 aluminum. So I'll go to Select. I don't have much to choose from. So in the material list, I'll right click and select Get from Library. I'm selecting aluminum inch 6061. I'll select OK. It's the current material. I'll select OK again. Now that I have this material selected, we can make some changes to the definition. So if I select Edit, under the material name, I'm selecting before the 6, and I'm going to backspace. So I'm using aluminum inch 6061-T6. Base cutting speed, set this to 300. For the percentage of base, I want to set this to 50% of the base cutting speed. So what I do is I left click on the 60, hit enter, type in 50, and hit enter again. And that will take care of all the changes that I need to make to this page. From here, I'll select OK. From here, go to stock setup. For the stock plane, I'm going to set this back to top. So I'll select this icon. I'll select top, select OK. So stock plane is top. For the shape of our material, now this is how we define our material inside of Verify. We have a solid model on our screen that accurately represents what the material is going to be. So for the shape, select solid / mesh. This icon is now available to us. This will allow us to get back into the graphics area. So if I select this icon, I can go back into the graphics area. And now I'm going to pick select the solid model that represents my material. The solid model selected or is highlighted, and you can see the dimensions of that solid in these fields. Just to get an idea where the solid is placed, I want to make sure that's placed correctly and it's the correct size. I'm going to select display. I'll select solid, and then I'll select OK. It doesn't look like much is going on. Reason being is the solid mesh is sitting on top of our solid model. If I go back to my level manager and I toggle off the solid model, what you're seeing is the red representation, or the red represents the material, or what the material is going to look like inside of Verify. It's not selectable. We can't do anything to it other than just verify that it's correct. So from here, I'll make the solid model level visible. I'll go back to the toolpath manager, and I'm going to toggle off the display of, oh, actually, I don't do that there. I do it over under the toolpath tab. In the stock section, select stock display. And this would be a good time for me to save my work. One last thing we'll do before we start bringing in stock models or toolpaths, where it says toolpath group -1. I need to rename this. Right click, groups, rename. I'm going to call this operation 1. Or first stop. I'm going to call it first stop. I like that better. Still don't know why this is like it is. I'm missing something. Probably going to cause some problems down the road. We'll see what we can do with it. All right. How's everyone doing?
Good. The level that you're active in right now should be still material.
Okay.
Or
All right. So from here, we're going to create our first stock model. And the stock model is going to represent the raw material, or what the material looks like prior to any machining. From the toolpath tab, I'll select stock model. On the first page, let's give it a name. We'll call it raw material or raw stock. For the stock plane, uncheck it. I want it to be set to top. And then for the initial stock shape, I'm going to use model. I'll select the cursor icon. And now I'm going to pick select the solid model that represents my material. From here, I'll select end selection. And on the first stock model that we create, there is no source operation. So from here, I'll select OK. And once I verify that it's correct, just toggle off the display of the stock model. And this would be a good time for us to save our work.
oh, Professor, quick question. Hello? Can you hear?
Still getting those red X's. Is anyone else getting those red X's?
Hey, Professor, can you hear me?
Is anyone there?
Professor?
Okay, hopefully I'm not talking to dead space.
I think his sound is off. You guys hear me?
Brian, are you trying to talk? I can't hear you.
Yeah, I can't. Yeah, I'm trying to talk. We can hear you.
Okay.
I don't.
I can hear you, both of you guys.
We might be experiencing technical difficulties. If anyone can hear me, say something or give me a thumbs up. Brian is
Yes.
trying to talk. Okay, I see that,
Yeah, I can hear you.
but
I'm
nothing is.
talking.
Okay, I get the thumbs up, so David can hear me. Cool. Okay. If you guys need to communicate with me, yeah. Just use the chat room. I've got that opened up. I can see it, but if you can, okay. So what level should we have active now? I don't have any, it doesn't really matter at this time until we create some type of geometry. I created my stock model or I created my material on the material level. All right, cool. All right. I'm having some issues with my machine group. Not quite sure what's causing it. File. Let me try one more time. CNC machines. Not getting it. Hopefully it doesn't cause too many problems. Okay. All right, so we've created my stock model, or we've created the stock model that represents our material. Now ready to create our first tool path. And what I'm going to do is I'm going to start by facing 20 thousandths off the top of the material. If you go to the project page and you scroll all the way to the bottom, you'll see the tool list. So tool number one, just like all of our other projects, we're using a 3-inch face mill 6 flute. And for the tool holder, we're just using the default. I'm going to go to tool paths. In the 2D section, I'll select face. Now I'm going to select the top edge of the solid that represents my material. Currently I'm set to wireframe chaining. That's not going to work in this case. So select solid. I'm now in solid chaining. The default settings, loop and face. If I position my cursor close to the top edge of the material, left click, the top edge becomes selected. From here, I'll select OK. I'll start by selecting the tool. I'll go to Tool. I'll select Library Tool. And chances are your filter is not active. So what you might want to do is check the filter or check filter active, select the filter icon. You might have several tools selected. So I start by selecting none. And then I select the type of tool that I'm looking for. With face mills, there might be 7 or 8. There's not too many. So I have my tool diameter set to ignore. I'll select OK. And from this list, I'm going to select the face mill that we're looking for, the 3-inch face mill. It's tool 324. When I double click on it, it should be added to your tool list as tool number 1. We're going to need to make some changes to the default settings of this tool. Right click on the tool, and then from the flyout menu, select Edit Tool. On the first page, we don't need to make any changes here, so I'll select Next. On the second page, let's start by setting the number of flutes to 6. To calculate the RPM, I'll select the calculator. That's a little slow, so we're gonna end up changing the cutting speed when we get over here. To turn on the coolant, select show more options, select coolant, and then set the flood coolant to on. I'll select OK. And that should take care of all the changes that we need to make here. So I'll select finish. I'm going to change the SFM. So the majority of the time in this class, we let Mastercam calculate our RPM based off of the 300 SFM. For the face mills, it doesn't work the way I want it to. So I'm going to actually enter this number manually. In the SFM field, type in 900. In the FPT field, type in 0.005. Set the plunge rate to half the calculated feed rate. So 34.38, divide that by 2. I've got rapid retract selected. And then in the comment field, what I'll normally do is I'll borrow the tool name, paste it in the comment field, and then in the comment field, enter any notes that you might want to use, all caps. And that should complete all of the changes on this page. For the holder, just use the default holder. Cut parameters. The diameter of the part is less than, I'm sorry, the diameter of the cutter is greater than the width of the part. So I'm going to leave this set to 1 pass. My approach distance, I have it set to 10%. Exit distance is 10%. Stock to leave on floors is 0. In this particular case, we're only taking 20 thousandths off the top of the material, so I don't need to use multiple depths of cuts. So I'm going to leave depth cuts turned off. Go to linking parameters. I want to set my clearance plane to 2 inches above the top of the material. If I activate clearance and then select the clearance icon, before you select the clearance icon, make sure it's set to absolute. So select the clearance icon, let your cursor lock on to the top endpoint. Relative to the origin, the top of the part is at 1.5 inches. I want my clearance plane to be 2 inches above that. So next to the value, I'm going to type in +2, hit enter. My clearance plane will be at 3.5 inches. Retract, I'm going to turn it off. Feed plane, I'm going to set it to 0.1 incremental. Top of the stock, I have it set to absolute. I'll select the top of stock icon. That allows me to go back into the graphics area. I'm going to let my cursor lock on to something that represents the top of the material. 1.5 relative to the origin, that's correct. For the depth, I'll set it to absolute. I'll select the depth icon. And now you'll have to have your graphics or your view set to translucent. I'm gonna let my cursor lock on to something that represents the top of the part. And you can see that's 1.48 inches. The difference between these two should be that 0.02 that we allotted for the material that's going to be removed. From here, I'll select OK. You can see a preview of the toolpath. I'm going to save my work. I'm going to select the entire first operation toolpath group. And actually, I just want to backplot the facing operation. So I'm selecting just the facing operation. I'll run it in backplot. I'll speed it up a little bit. From here, I'll exit backplot. I'll toggle off the visibility of the toolpath. Still trying to figure out what's going on here. I'm now going to run this toolpath inside of Verify. So I'll select the entire first operation toolpath group. I'll select Verify. It's going to open up another window. Once Verify opens up, make sure that stop condition collision is turned on. I'll increase the precision a little bit. I'll slow it down. This will be quick. And we're just taking the 20 thousandths off the top of the material. And that'll get the top, that'll get the machine face planar with the top of the part. From here, I'll exit Verify. And I'm going to keep minimizing the stock models and the tool pads after I verify that they're correct. That way it makes more space, or it frees up room inside of the toolpath manager. How's everyone doing up to this point? All right. From here, we're going to create a stock model that reflects what this facing operation has done. I'm going to go to the toolpath tab. In the stock section, stock model. In the name, we'll call this facing first, or facing first operation. For the initial stock shape, we're going to use the stock model, the raw material stock model. So I'll select stock model. From the drop-down menu, I'll select raw material. For the source operation, I'm going to select the toolpath that we just created, and then I'll select OK. Once Mastercam creates the stock model, you want to inspect it, make sure that it's correct. And it's difficult to see, but you can see a slight color change. The stock model is slightly smaller, or slightly shorter than the solid model that represents the material. From here, I'll toggle off the visibility of the stock model, and I'll save my work. How's everyone doing? I cannot hear anybody. Good.
Hey, Professor,
All right.
can you hear me?
Brian, if you're talking, I can't hear you.
Hello, test, test, test.
Okay, cool. As long as you guys can hear me, that's what matters. Okay, so from here, we're going to move on to the next operation. What we're going to do, we're going to create toolpaths very similar to the Softjaw mill project. We're going to have a dedicated roughing tool and a dedicated finishing tool. If I go back to the project page and I look at the tool list, tool number 2, this will be our 1-inch flat end mill 3 flute. We're told to use a specific tool holder. And this is the roughing tool. We're going to deliberately leave 20 thousandths of material on the walls. And then we're going to come in with a dedicated finishing tool, tool number 3, and we're going to machine the part to its finished dimensions. Back inside of Mastercam, I'm going to go to toolpaths. In the 2D section, select contour. I'm now going to select the top edge of the part, and I'm going to use wireframe geometry to do that. So I'm going to change back to wireframe mode. So I'm now in wireframe chaining mode. C-plane is selected, and then the selection method is chain. I'm going to select the top edge of the part. You can see that the chain is going in a clockwise direction. That way we will be climb cutting. From here, I'll select OK. We're in the parameters for the tool path. I'll start by selecting the tool. We're going to use a 1-inch flat end mill. So I'll go to Tool. I'm going to add that tool to the tool list. So I'll select Library Tool. My filter is active, so I'll select the filter icon. I'll start by deselecting all tool types, and then I'll select the type of tool that I'm looking for. I'm looking for a flat end mill. And for the tool diameter, I'll set it equal to 1. And then I'll select OK. I've got one tool that fits that description, tool 297. If I double click on it, it's added to my tool list is tool number 2. I'll need to make some changes to the default settings. So I'll right click on it. From the file menu, I'll select edit tool. If I look at the project page, they're telling me that the tool projection is 2 inches. Cut length is 2. Shoulder length is 2.5. So I'm going to need to change the shoulder length to 2. So shoulder length is 2. From here, I'll select next. On this page, set the number of flutes to 3. To calculate the RPM, select the calculator. To turn on the coolant, select show more options. Select coolant. Set the flood coolant to on. And then select OK. That'll take care of all the changes that I need to make to this page. From here, I'll select finish. The RPM has already been calculated from this 300 SFM. For the FPT, this is how we control the feed rate. Set the feed rate for the FPT equal to 1% of the tool diameter. So 1 times 0.01 is 0.01. My feed rate is 34.38. I want to set my plunge rate to half the calculated feed rate. So 34.38, divide that by 2. I've got rapid retract selected. And then in the comment field, I want to provide some type of comment that will be useful to me out of the machine. So I'll borrow the tool name. Say rough outside contour. From here, go to the holder. We're instructed to use a C4 E3-1000 and the tool projection will be set to 2 inches. So this will be a Cat 40 type tool to go to open library, CT 40 inch. I got to double check that holder again. So C4 E3 1000, C4 E3 1000. Set the tool projection to 2. And that'll take care of all the changes that we need to make to this page. From here, go to cut parameters. Compensation should be set to where. Compensation direction is left. My contour type, I need to change this to 2D. Yours is probably already set to 2D. Stock leave on walls, I have it set to 0. Stock leave on floor, set to 0. we're going to use multiple depths of cut. The depth or the height of this part is greater than half the diameter of the tool. So I'm going to set depth cuts to on. I'm using the default values that Mastercam has provided. So max rough step should be 0.5. And I've got keep tool down selected. From here, I'll go to lead in, lead out. For my entry and my exit, everything is set to 25%. Breakthrough, it's currently turned off. I'm going to activate it and set the breakthrough amount to 0.02. Multipass, I have it turned off. This is a dedicated roughing tool. We're going to come in with a dedicated finishing tool, so I'm not worried about programming a finish pass with this particular tool. So I've got multipasses turned off. From here, go down to linking parameters. We're going to use the same clearance plane that we used for the first operation. So set this to 3.5, absolute. Retract, I'm going to turn it off for the time being. Feed plane, I'm going to set it to 0.1, incremental. Top of the stock, I have it set to absolute. If I select the top of stock icon, let my cursor lock on to the top of the part. For the depth, I have it set to absolute. I'll select the depth icon. I'm going to zoom in and I'm going to pick select something that represents the bottom of the part. And it should say relative to the origin, the depth is 0.23 absolute. And that should take care of all the changes that I need to make. From here, I'll select OK. I'll fit my screen. I'm not seeing any major issues with the toolpath. I'm going to run it in backplot and see what I get. So with just that toolpath selected, I'll select backplot. Okay, I like what I see. It's going to machine that profile out in 3 depths of cut, and it's going to intentionally leave 20 thousandths material on the walls for our finishing tool. So once you verify that everything is correct or verify that there's nothing wrong inside of backplot, exit backplot, save your work. I'm going to run the entire first operation in verify. So I'll go to verify. Stop condition collision is turned on. Then I'll select play. Inside of verify, I can inspect the machined model. And I can see right away that I did not leave any material on the wall. Now it's difficult to see because the machined model is yellow and my wireframe geometry is yellow. I go to verify and turn on the color loop. I can see that now it's a different color. I can see the machine model matches my wireframe. I forgot to leave material on the wall. So I'm going to exit verify. I'll go into the parameters for that contour. Go to cut parameters where it says stock to leave on walls, 0.02. I'll select OK. I need to regenerate that toolpath. So I'll select regenerate all dirty operations. Okay. I'll rerun that inside of verify. So I'll select the entire first operation toolpath group. I'll select verify. Stop condition collision is still turned on. I'll select play. Now, if I zoom in, still a little difficult to see. I'm going to change my wireframe from solid geometry color here when we get back into, when we get out of verify. But you can see I've got some material left over that still needs to be removed. Level manager, I'm going to change the wireframe color. A quick way to do that is if I go to select all entities by level, wireframe from solid. And if I go to the home tab, I'm thinking that's not good either. Try this gold color. That's not what I wanted. All right, let's see here. Try that bluish color right there. Okay.
Professor, can you hear me?
Save my work.
I can hear you, Rodrigo.
Yeah,
Back
it's
to the
weird.
toolpath manager. I'm now going to create
what's going
a
on.
stock model that reflects what we just did with this contour toolpath. Go to toolpaths. In the stock section, I'll select stock model. For the name, we'll call this rough outside contour. For the initial stock shape, we're going to use a stock model. I'm going to select the stock model that we created with the previous stop. And then for the source operation, I'm going to select the contour toolpath that we just created. Now it's difficult to see if I go back to my level manager and turn off the solid model. And if I turn off my material, that's what the part currently looks like inside of the machine. Make the material level visible again, and I'll make the solid model visible again, and I'll make the stock model invisible. And for the time being, I don't need to have my material level visible, so I'll go back to the level manager, make the wireframe from solid the active level, make the material level invisible. The next thing we'll do is we're going to sheen the outside profile to its finished dimensions. We're going to use that 3/4 inch flat end mill to do it. That'll be our dedicated finishing tool. Tool 3 is going to be a 3/4 inch flat end mill, 3 flute. We're instructed to use a C4E3-0750 tool holder, and we have a tool projection that's 2.5 inches. I'll go to toolpaths, 2D contour, selection method, chain. I'm going to select the outside edge of the part so that the chain goes in a clockwise direction. I'll select OK. I'll go to the tool. We're going to add that 3/4 inch flat end mill to our tool list. So I'll select library tool. My filter is currently active, so I'll select the filter icon. I'm still looking for a flat end mill, but this time I want to set the diameter value equal to 0.75. I'll select OK. I've got one tool that fits that description. It's tool 294. When I double click on it, it's added to my tool list as tool number 3. We'll need to make some changes to the default settings. So I right click on the tool. I select edit tool. The shoulder length is 2.5, so that'll actually work because the tool list is calling for a 2.5-inch tool projection. So from here, I'll go to next. I'll set the number of flutes to 3. To calculate the RPM, I'll select the calculator. To turn on the coolant, I'll select show more options. I'll select coolant. Then I'll set the flood coolant to on. And then select OK. That should take care of all the changes that we need to make to this page. So I'll select finish. The spindle speed is calculated or based off of this 300 SFM. Let's set the FPT equal to 1% of the tool diameter. So 0.75 times 0.01. We'll set the plunge rate to half the calculated feed rate. So 34.38. Divide that by 2. I've got rapid retract selected. In the comment field, I'm going to borrow the tool name. And then in all caps, I'll provide some type of useful information. We'll say machine, or finish machine, or finish pass. Outside contour. The tool holder, I'll start by selecting the Cat 40-inch tool holder library. We're going to use a C4E3-0750. And set the tool projection to 2.5. From here, we'll go to cut parameters. Compensation type should be set to where, contour type is set to 2D. Make sure you set the stock to leave on walls, set that to 0. This time we're machining it to the finished dimension, so we do not want to leave anything on the walls. Depth cuts, we're going to turn this off. We're going to machine this finish pass at 1 depth or at the final depth. Lead in, lead out. I'm using 25%. These are my default settings. Breakthrough. I'm going to use the same breakthrough that we use for the roughing pass. So breakthrough is set to 0.02. Multi passes, I have it turned off. And then if you go to the linking parameters, I'm going to use the same clearance plane as the 2 previous operations. So 3.5 absolute. Feed plane is set to 0.1 incremental. Top of the stock is set to absolute. I'll select the top of stock icon. I'll select the top of the part. And then for the depth, I have it set to absolute. I'll select the depth icon. Once again, I'm going to select something that represents the bottom of the part. And then I'll select OK. I'm not seeing any issues with the tool path. So from here, I'll toggle off the visibility of the tool path. I'll select it and I'll run it in backplot. Actually, I toggled it off too soon. Looks good. Before I go into verify, I want to save my work. I'll select the entire first operation toolpath group, and then I'll run verify. Inside verify, make sure stop condition collision is turned on and run it. Once verify is complete, I inspect the model and I'm just making sure that there are no collisions. And I check to see if the machined model matches up to the wireframe representation of the part. From here, I can close out of verify. We still need to spot drill, counterbore, engrave, and break any sharp edges that we might create. If I go to the projects page and I look at the tool list, we're just gonna create the tool paths. Try to follow the order that the tool list is using. So the next tool that we're going to use is the 1/2-inch diameter spot drill, 90-degree DPA. So we're gonna create the pilots for the holes that go all the way through the soft jaw. And we're gonna create a pilot that's 0.25 in diameter. And this is gonna be used just to guide this 11mm drill. Back inside of Mastercam, we need to create a stock model that reflects what that last toolpath has done. So I'll go to Toolpaths, Stock Model. We'll call this one Finish Contour. First stop. Or just call it Finish Contour. It's the only one that we have. For the initial stock shape, we use a stock model. So select the last stock model that we created. And then for the source operation, select the tool path that we just created. I'll select OK. Mastercam generates the stock model. And once again, I just want to make sure that everything looks correct. I'm not seeing any issues. Once you verify that it's correct, you can toggle off the visibility of the stock model. And I'll save my work. How is everybody doing up to this point? Thumbs up, thanks. Okay. We're going to create the pilot using a 1/2-inch diameter spot drill. We'll go to tool paths. We're going to go to 2D section, drill. So select one or more entities, add or remove from the features list. I'm just going to select the 2 circles that represent the counterbores. I'm not concerned about the diameter values because these circles, I'm just picking up the center points of these circles. And this is how we tell Mastercam where to drill or where to center this drill. So I got 2 points. From here, I'll select OK. Go to the tool. We're going to add that 1/2-inch diameter spot drill to our tool list. So I'll go to select library tool. I'll select the filter icon. I'll start by deselecting all tool types. And then I'll select, that's the chamfer mill. We want to use the spot drill. And for the tool diameter, I'm going to set it to ignore. Select OK. We're looking at all the spot drills available from this tool library. I'm going to select the 1/2-inch diameter spot drill. If I double click on it, it's added to my tool list as tool number 20, or I'm sorry, tool number 4. I'll need to make some changes to this tool. So right click, edit tool. I'll start by changing the cutting length. Let's set this to 0.25. And then set the shoulder length to 1. Select next. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. You can calculate the RPM by selecting the calculator. To turn on the coolant, select show more options, select coolant, set the flood coolant to on, and then select OK. From here, I'll select finish. The RPM has already been calculated. The FPT, think of this as feet per revolution. Set this to 2% of the tool diameter, so 0.5 times 0.02. It's calculated my feed rate at 11.46 inches per minute. In the comment field, I'll borrow the tool name. And then I'll provide some type of useful comment or useful information. So drill, they need to be capitalized. So drill all pilots. For the holder, we're gonna use a CAT 40 ER32 tool holder. Go to Open Library, CT 40-inch. We're gonna use a C4 C3-0032. And then set the tool projection to 1.5 inches. That'll complete all of the changes that we need to make on this page. Go to cut parameters, just verify that the cycle is set to the drill /counterbore and the dwell value is set to 0. From here, jump down to linking parameters. We're going to match our clearance plane to the previous toolpath. So set clearance to 3.5 inches absolute. I'm going to select use clearance only at the start and the end of the operation. Retract set at the 0.1 incremental. Top of the stock, set it to absolute. Select the top of stock icon, and then let your cursor lock onto the top of the counterbore. For the depth, set it to absolute. Select the depth calculator. Select overwrite depth. Set the finished diameter to 0.25 and then select OK. Mastercam has determined the depth based off of the size of the counterbore. I'm sorry, size of the countersink, size of the pilot hole. From here, make sure tip comp is turned off and then select OK. I'm not seeing any issues with the toolpath just yet. So from here, I'll run the toolpath in backplot. Everything appears to be fine inside of backplot, so I'll select OK. I'll toggle off the visibility of the toolpath. I'll save my work before I go into verify. I'm selecting the first operation toolpath group, and then I'll select verify. Inside of verify, make sure stop condition collision is turned on, and then select play. Once verify is complete, I'm comparing the machine model to the wireframe model. Everything looks good. The pilots, these are going to be used to guide the 11mm diameter drill. So from here, I'll exit verify. I'm going to create a stock model. I'm going to create a stock model that represents what the previous toolpath has done, or what we've done up to this point. I'm going to go to toolpaths, stock model. For the name, I'll call this one pilot holes. For the initial stock shape, we're going to use a stock model from the previous operation. Then for the source operation, we're going to select the toolpath that we just created. Select OK. Once Mastercam creates the stock model, just verify that it's correct. If everything looks good, you can toggle off the display. And once again, I'll save my work. How's everyone doing?
Good.
All right. Okay. So from here, I'm going to create the holes that go all the way through the part. If I look at the project page, tool number 5, this is an 11 millimeter diameter drill. It's got 118-degree DPA, and we're gonna use a Cat 40 ER32 tool holder. And the tool projection will be set to 3 inches. Now, what's different about this particular tool is that it's in millimeters. We're going to go into a millimeter tool library and get a tool from that library. We've been looking at the an inch tool library up to this point. So let me show you how this works. I'm going to create a new drilling operation. I'm going to go to Toolpaths, 2D drill. I'll select the tops of the counting boards. Once again, we're just picking off the center points. So as you select these circles or the tops of the counting boards, make sure a point is placed at the center. From here, I'll select OK. I'll go to Tool. I'm going to go to Select Library Tool. Now, I'm currently looking in the mill inch tool database. We're going to change that to the metric tool database. So I'll select New Library. You scroll to the bottom, you'll see mill millimeters or mill mm. Select it, select Open. My filter is active, so I'll select the filter icon. I'll start by deselecting all tool types, and then I'll select drill. And for the tool diameter, I'm going to set it to less than 0.5. Now it's still reading in inches. I'm looking for an 11 millimeter. That is a half inch tool is 12.7. Another way we could approach it, if we were to type in 13, or better yet, 12 mm and hit enter, it's going to show me tools that are smaller than 0.472 in diameter. Now it's a little confusing because we're working in inches, but we're looking for a millimeter tool. So what I did here, we're looking for a 11 millimeter tool. I just said less than 12 mm, or better yet, I could say equal to 11 mm. And let's see what Mastercam shows us. I'll select OK. I've got 2 tools that fit that description. So that's a little confusing. That's because we're toggling back and forth between metric and inches. There's actually, we're working in inches. We're just looking for a metric tool. I'm going to select tool 65. I'll select OK. It adds a tool to my tool list. Is tool number 5. Right click, edit tool. I'm not going to make any changes to this page. I'll go to the next page. I'm going to set I'm not going to make any changes to this one. I'm going to select the calculator. Mastercam's calculating the RPM. I'll select show more options. Select coolant, set the flood coolant to on. From here, I'll select finish. The RPM is being calculated from this 150 SFM for the FPT. We're going to set this equal to 1% of the tool diameter. I'll take the decimal equivalent of the tool diameter. I'll type it down here, 0.433, multiply it by 0.02 times 0.02. We're calculating our feed rate at 0.0087 inches per revolution. In the comment field, I'm not liking the tool name here. Let's just call this an 11 millimeter drill. 118 degree. So I'll borrow this tool name. Paste it down here. All caps, drill all holes through. And with that said, I had to change all of this to all caps. Go to the holder. We're going to use a Cat 40-inch ER32. So I'll go to Open Library. I'm going to go to Cat 40-inch, open. C4C3-0032. We're going to use a 3-inch tool projection. So set the tool projection to 3. Not letting me do it. I need to go back into, so let's do this. Let's set the tool projection to 4. That will work just fine. And I'll make a change to these instructions. So let's set this to 4. I'll do that right now. All right. From here, I'll go to cut parameters. It should have changed over to a peck drill increment. For the peck increment, I'm going to type in 11 mm and then multiply it times 0.3. I'll do that again. I'm setting the peck increment equal to the drill tip length. So I'm starting with the drill tip diameter, 11 mm, enter. It calculates the inch equivalent. And then next to that value, I click, and then I type in times 0.3. The drill tip length, if it was 118 degree DPA, is 0.1299 or 0.13. From here, I'm going to go down the linking parameters. Clearance is the same as the previous tool paths. I'm using clearance only at the start and the end of the operation. I have retract 0.1 selected, or retract set to 0.1 incremental. Top of the stock, I have it set to absolute. I'll select the top of stock icon. I'm letting my cursor lock on to the top of the counter bore. And then for the depth, I have it set to absolute. I'll select the depth icon. I'm going to lock on to something that represents the bottom of the part. From here, I'll go to tip comp. Let's activate tip comp and set the breakthrough amount to 0.025. And that should complete all of the changes that we need to make here. I'll select OK. I'm looking at the tool path and I can see that the tool does go all the way through the part. And when it repositions from one hole to the next, I don't see any collisions. So from here, I'll run this tool path in backplot. So with just that tool path selected, I'll select a backplot. Looks good. So from here, I'll exit out of backplot. I'll toggle off the display of the tool path. I'll make sure I save my work. I'll select the entire first operation toolpath group, and then I'll run it and verify. Inside of verify, make sure that stop condition collision is turned on, and then I'll run it. Once it's done running inside of Verify, I want to inspect the model. Something that we can do, we can actually toggle or change over from a solid view to a translucent view. So where it says stock, select it. It'll change from a check to a square. We now have a translucent view. If I look at it from a front view at this time, and I zoom in, you can see that the full diameter of the drill goes beyond the bottom of the part, and that's what I want. Change back to a shaded view. From here, I'll exit Verify. I'll need to make a stock model that reflects what we just did or reflects everything that's been done up to this point. I'll go to stock model. Call this one drill holes through. For the initial stock shape, we'll use a stock model from the previous operation. And then for the source operation, we're going to use the peck drilling operation that we just created. Mastercam creates the stock model. Want to make sure that everything is correct. I'm not seeing an issue. So from here, I'll toggle off the visibility of the stock model. I can look at it from an isometric view. And this would be a good time for me to save my work.